Hey guys, today we're going to talk about electric charges and forces. We've already studied atoms, so you guys know a little bit about this. You know the basics that protons have a positive charge and electrons have a negative charge. And you can see in the picture there, you've got a proton with some arrows pointing out showing that's where the positive charge goes, and you have an electron showing the same thing where its charges go. And you can see that those two kind of look like they're joining together. And the fact that we have protons and electrons, they are attracted to each other and they join together to kind of hold things together. So we're going to talk a little bit about how electric charges move and the forces that are involved. And this is going to all kind of end up with us learning about electricity and how electrons move through different wires and things to create electricity. So kind of a review, we've talked about the atoms, and atoms contain those three subatomic particles. We've got protons, neutrons, and electrons. You guys know that there are two types that have a charge. The protons have a positive charge, and the electrons have a negative charge. So if you have an atom that has the same number of protons and electrons, it becomes electrically neutral. In other words, the proton and electrons cancel each other out. So if you've got 5 protons and 5 electrons, they each kind of account for each other, and you end up with a neutral atom that has no charge. If the charges are not balanced, the object is electrically charged. So you can see in our diagram down here, the red protons, it looks like we have 3 of them, and we also have 3 electrons in that electron cloud on that orbit around the nucleus. There's 3 of each. So this would be electrically neutral. Now, if this gained an electron, and you can gain an electron from stealing from another item when you rub against each other by contact is what it's called, charging by contact. They actually steal an electron from another atom. If this had 4 electrons and 3 protons, this would be electrically charged. It would have a negative electrical charge because it's got more electrons than protons. So the forces that these exert on each other, obviously the electron, as you guys know, has the negative charge and the proton has the positive charge. When they come near each other, they exert a force on each other. Now, like charges repel one another. So by saying like charges, I'm talking about two things that are the same. They're alike. So if you have 2 protons next to each other, they're going to push away from one another. Or if you have 2 electrons next to one another, they will also push away from each other. They do not want to be near each other. Opposite charges attract one another. So if you have a proton and an electron, they actually pull toward each other and they want to be attracted to one another. The electric force increases with increased charge. So if you just had 1 proton and 1 electron, you wouldn't have much of a charge. But if you had 1 billion protons and 1 billion electrons, that would be a really strong charge holding them together. And that's why we talk about when you have atoms with different numbers of protons in their nucleus, we talk about the amount of power that they would have because they're holding together different things. If you look at hydrogen, atomic number is just 1, so it's only 1 proton, so you're not going to have a whole lot of force. But if you're talking about something like ununquadium, which is an atomic number of 115, that's got a ton of protons in it, so it has a lot of force holding all the electrons in place. It'll also decrease with increased distance. That's kind of hard to understand, but all it's saying is if you have a proton that is really close to an electron, they're really like next to each other, they're going to be attracted to one another because they're so close. On the other hand, if you have a proton and an electron that are 20 feet away from each other, they're not really going to have an electric force on each other because they're just too far away. Their electric field, in other words, those charges that come from them, it just doesn't reach that far. It's too much distance. So how do the charges change? When you have an electric field, you have this area that surrounds a charged particle. And that's what this thing is back at the beginning here of the video. You can see all these different arrows and stuff going around the protons and electrons. That's an electric field. So it's not like they have to be touching each other in order to impact each other. That proton and electron are attracted to each other because they're opposites. And notice they weren't touching each other, they were just in the same area. So you've got 2 different ways to have protons and electrons kind of impact each other. The first one is called charging by contact. And that's where electrical charges are transferred by movement of electrons. That means the electrons actually move from one object to another. And an example is rubbing a balloon on your head. You'll see the electrons actually go from your head to the balloon. Charging by induction, the electrons rearrange within an object. So in charging by induction, the electrons don't leave the object, they stay in the object, but they get rearranged in a different formation. And an example is sticking a balloon to the wall. So after you rub it on someone's head, you guys have probably rubbed a balloon on your head before or on your sweater or something like that. You can stick it on the wall or you can stick it on the ceiling and it'll stay there. And the reason that is because of charging by contact is the rubbing the balloon on your hair or on your sweater, and charging by induction is when you can stick it there because the electrons rearrange. Now I'm going to show you guys a little drawing I did of this. We'll also talk about this a little bit more in class, and you guys will see this live and we'll do some demonstrations with it. But check out my awesome drawing skills. Alright guys, so we talked about charging by contact and charging by induction on the video. We're going to do a little more with charging by contact. And this is the one where the electrons actually move from one object to another. One object will steal the electrons from another. So like I told you on the video, the example is you have a person. We'll give this person some beautiful green hair, a nice little smiley face. This person is going to have a balloon rubbed on their head. And what's going to happen is when this hair starts out, the hair has an equal amount of protons and electrons in it. Okay, we'll say, for example, it's got 2 protons and 2 electrons. The balloon, when it starts out, also, we'll say, has 2 protons and 2 electrons. Therefore, they are both electrically neutral because these protons and electrons cancel each other out. These ones cancel each other out. These cancel, these cancel. So each object is electrically neutral. But what happens when you take the balloon and you rub it on the person's hair, the balloon is rubbing all over this hair, and it's actually going to steal one of these electrons. And it's going to gain that electron. Now, you have a hair that is missing an electron, so it has a positive electrical charge because it has 2 protons and 1 electron. And you have a balloon that has a negative charge because it has 3 electrons and only 2 protons. So in charging by contact, the electrons move. Okay? The electrons move from one object to another. So the electrons go to a new object. So they actually kind of like find a new home. Okay, so that one's charging by contact. Now, on the other hand, charging by induction looks like this. Okay, in charging by induction, you don't actually lose electrons from one object to another. Let's talk about that balloon that just was rubbed on the person's hair. Okay, here's our balloon. And we said after it was rubbed on the hair, it had 2 protons, but it had 3 electrons. So it had a negative charge. Now I'm going to take that balloon and I'm going to stick it on the ceiling. Okay, this is kind of like a cross section of the ceiling. And in our ceiling, it has an equal number of protons and electrons. It's all kind of balanced out here. So it is electrically neutral. But what happens when you bring the balloon toward the ceiling, the balloon has a negative charge. And since opposites attract, the positive charges are going to stay. But like charges, electrons and electrons, they repel. So what's going to happen when I put this balloon up close to the ceiling, these electrons are going to move to the back part of the ceiling. And so what this ceiling tile is going to look like, even though the ceiling tile as a whole is electrically neutral because it still has the same number of protons and neutrons, what happens is it gets divided into almost 2 different areas. So no longer is this one here, it's moved up here. No longer is this one here, it moved up here. No longer is this one here, it's moved up, and the last one did the same thing. And so when you bring the balloon up toward the ceiling, what you have is this balloon has a negative electrical charge because it's got 3 electrons and 2 protons. And this part of the ceiling tile has a positive charge because it has the 4 protons that are down toward the balloon. So this balloon is going to stick on the ceiling because there's an attraction there. Now eventually what will happen is these electrons will move back down because one of these electrons will give off to the air and get back to balance, and when these electrons move back down, the balloon will fall to the ground. So hopefully that helps you understand a little bit more about charging by contact, charging by induction. We're going to do these in class tomorrow, so you guys will get a first-hand experience with it. All right, guys, so hopefully that helps a little bit more. We will do these in class, and I'll show you. I'll rub some balloons on your heads tomorrow. You guys do it to each other. We'll talk about how those electrons move. So don't forget quiz on the back. You guys have a great night. I will see you all tomorrow.